In this video, we're going to look at Endmill selection and RhinoCam setup for milling with the Shapeoko. What you see here is a project that I worked on a couple years ago, and this wasn't milled on the Shapeoko, it was milled on a larger CNC machine. But what you see here are some different size engraving paths. So this is a larger one, and this is a smaller engraving pass, and then you also see a pocketing pass, which takes out a large portion of material set to a certain depth. And if we look a little closer, we can see some of the detail of this project. So let's get started with Endmill selection. So I'm here at inventables.com, and I'm going to go down under bits and tools, and I'm going to take a look at their milling bits. So it's important that we're using end mills with the Shapeoko, not drill bits. End mills are meant to move laterally and can move and mill sideways. So we'll take a look at the milling bits. And I'm going to narrow my results to 1/8 of an inch. And what we're going to be using three different types of bits. The first one is going to be an engraving bit. It's going to scratch the surface and give us very fine line work. And then we're going to increase our line work in width to about 1/16 using this Fishtail 2-flute spiral bit. And then we're going to look at increasing our width to 1/8 inch. We'll look at the single flute upcut, and we'll look at the straight flute downcut. So let's start with the solid engraving bit. Now notice the cutting diameter on this engraving bit is very small. It's 0.01 inch. But the shank is 1/8 inch, and that's the rotary tool that we're using. And let's look a little bit closer at this. So there are no flutes on this end mill. So it's not good to go into the material very deep, because you won't be able to clear away the material or remove the chips. That's what the flutes will do for you. So this is just an engraving bit, just meant to scratch the surface. And this distance is about 1/2 inch between the tip of it to the shank. And now let's go look at the second type of end mill that we're going to be looking at, which is a fishtail. And we're going to use the 1/16 inch, so we'll get a little bit heavier lines than we can get with the engraving. But the other thing that we can do is we can go down into the material deeper. We can step down into the material, and we're going to be stepping down into the material at about 1/2 of a millimeter, about 0.02 inches. And these flutes, these two flutes, will clear the material away as it's milling and reduce the heat. Heat is our enemy when we're milling with the Shapeoko. Okay, and our third type of end mill that we're going to look at is a 2-flute straight. Okay, and currently they're not selling these separately, so you have to get them in packs of 10. And we'll take a closer look at this. So there are 2 flutes. There are one on each side, but they're straight flutes. And the benefit of a straight flute is it pushes down. It's a down cut end mill. So it keeps your stock down. Pushes it down onto the Shapeoko. It doesn't lift it up. So that's the benefit, that it keeps the stock down. The negative would be that it could generate too much heat, and if you're milling an acrylic, it can start to melt the acrylic that it's cutting back onto the stock. So you have to just experiment with that and see what works best for what you're actually milling. And the fourth end mill that we're going to look at is going to be an upcut. It has a single spiral flute, and the pros of having a single flute is that it can clear the chips away faster and generate less heat. The downside is it could possibly lift up the material. So it's really a trade-off between the straight flute and the spiral flute. Now the last two that I looked at, this upcut Endmill and the downcut straight flute, they both have cutting diameters of 1/8 of an inch. So these are good for thicker engraving and also for pocketing. Now most of these end mills can also be found as part of a starter set. So if I go back to milling bits, narrow my results to 1/8 inch, down at the bottom here you'll see end mill starter set. There are 2 starter sets available. Now neither of these have an engraving bit. The good news is the engraving bit was only $2. You'll also see an additional end mill that's in here, which is a ball end mill that we'll use later on for surfacing. The second kit includes a fishtail that's 1/16 of an inch, and it also includes a fishtail end mill that's 1/32 of an inch. Now the 1/32 of an inch is very small and it's very brittle, so I would recommend using very slow feeds if you're going to try the 1/32 inch, very slow, or else it's just going to snap. Okay, let's head over to Rhino and RhinoCam and set up a file for milling. So 2 things that I want to make note of. One is the units. We have to set our units to inches, and the default units in the lab is set to millimeters. So I'm going to type in DOC, which is short for document properties, and I'm going to go to units, and I'm going to make sure that my model units are set to inches. I can't do this later on after I've set up cam data, or else it will erase the cam data. So I have to do this first. Also, while I'm here, I'm going to change the grid. So I'm going to set my grid line count to 10, because we're going to be working with a stock size of 10 by 10, and I'm going to set my minor grid lines to every 1 inch. And I'm going to go ahead and work in my perspective view. Now the second thing that we have to be sure of is that our RhinoCam is not set to lathe. The default in the computer lab is lathe. So I need to go up to RhinoCam 2014 and set that to mill. And now I see the proper machine, which is a 3-axis machine. The next thing I need to do is change my post. So I can double click on post, and you want to browse for your flash cut pre6inch.spm file. Okay, so our stock. I mentioned we're going to be working with a 10 inch by 10 inch stock, and we're going to use 1/8 inch acrylic. So I'm going to begin by drawing my stock in Rhino. So I'm going to create a rectangle from 0, 0, 0, and I'm going to go to 10, 10. So 10 inches by 10 inches. That's the outline of my stock. Now I want to actually create my stock thickness, which is going to be 0.125 or 1/8 of an inch. So I have a layer set up that is already called stock. And the way that I created this stock, if I go ahead and delete this stock, is I made my stock layer current and I extruded this curve. I'm going to select this curve, start to type in extrude, choose extrude curve. Now you see I can extrude this in the positive direction and the negative direction. So it's important that I extrude this downward. So I'm going to put in the thickness of my acrylic, which is 0.125, but I'm putting negative first in the command prompt. So negative 0.125. And it's important that my solid is set to yes, so that it actually caps this extrusion. And I can hit enter. And you just want to make sure that this extrusion is negative, that the top left hand corner is 0, 0, 0. Okay, so that's set up. Now I can set up my stock to fit the virtual stock that I've drawn in Rhino. So I'm going to go ahead and double click on stock, and I'm using the top left hand corner of the stock to be 0, 0, 0. Make sure the stock equals the size that you're working with, so 10 by 10 by 0.125 or 1/8 of an inch, and I'll click OK. So now my stock is set up. The next thing that I need to set up is my work zero. So I'm going to go ahead and click on work zero, and for this piece I want my work zero to be XYZ, all set to 0. I can click on generate and my work zero shows up. So the first machining pass that I'm going to create is going to be an engraving pass. And for this engraving pass, I'm going to actually set up the engraving bit. So I'm going to go to 2 axis and I'm going to choose engraving. And the first thing that it wants me to do is select my drive containment regions. So I'm going to click on that, and I have those on a layer called engraving 1. And I can either select all of those in Rhino, or I can right click on engraving 1 and choose select objects, which selects the objects only on that layer. And I'll hit enter. Okay, so all those are showing up in the machining regions. The next thing I need to set up is my tool. So I'm just moving left to right, and then I'll move up to the second row and again move left to right. So I'll click on tool, and I'm going to click on edit, create, select tool. And I have some different types of end mills to choose from. I have ball mill, I have flat mill, corner radius mill, and I have a V mill, which matches closely to an engraving end mill. So I'm going to go ahead and click on that, and I'm going to go ahead and rename this. I'm going to name it to the end mill that I'm using, and we're going to be using an engraver. Now the engraver diameter was extremely small. It was actually from Inventable's website there, it said it was 0.01 inches. And it had a taper angle of 30 degrees. Now it's very thin. It's a very thin line you see here in this preview. The tool length, I'm going to set that up to be 0.5 inches, so 1/2 of an inch. And the shoulder length, I'm going to set up to be 1/4 of an inch, so 0.25. Now this end mill has a larger shank. It's not 0.01 at the shank, it's actually 1/8 of an inch. So I can put that in for the shank diameter, so 0.125. Okay, now the holder diameter is going to be 0.5, so that's the collet on the rotary tool. That'll be 0.5 inch, and the holder length can also be 0.5. So now this preview updates. So we have our very thin engraver, and then we have our shank of 1/8 of an inch, and this just represents the collet on the rotary tool. Next thing we need to set up are our feeds and speeds. So I'm going to set that up for this tool. I'm going to click on feeds and speeds, and the spindle parameters for my engraving, I'm going to set that as fast as it can go, and on that rotary tool that's 35,000. Now this doesn't actually set the spindle speed. That's something that I have to do manually on the rotary tool. I have to set the speed to the max, the maximum rotations per minute. Now my feed rates, I'm going to use 35 for the plunge, approach, and engage. So I'm going to go relatively slow into the material, and then once I've engaged the end mill with the material, I'm going to go a little bit faster. So I'm going to change these all to 70. Okay, and I'm going to save this as a new tool. And click OK. Next are my feeds and speeds. So I want to make sure that these reflect the settings I just created. And if they don't reflect the settings, I can click on Load from Tool, and those should show up. Okay, next is my clearance plane, and I want to save as much time as possible when I'm milling, so I want to bring this down relatively close to my stock. So I'm going to choose absolute Z value, and I'm going to lower that down a little bit higher, so about 0.15 above my stock. Next are my cut parameters. Now it's important that the location of my cut geometry is set to top. Then I can set my total cut depth. Now for this engraving, I can't go very deep. I can't keep stepping down into the material because it has no flutes on the engraving end mill. So I'm going to set my total cut depth to 0.02, which is about half of a millimeter. Then I'm going to click out of that window and just make sure that my rough depth shows 0.02. Then I can move on to my entry and exit, and I can leave that as the default. And I can change my sorting to minimum distance sort. And I can click on generate. Okay, so I want to simulate this to make sure that it's doing what I want it to. So I'm heading over to the Simulate tab. I'm going to right click on Engraving, and I'm going to choose Simulate. Okay, it went super fast. I could hardly see anything. So what I can do to slow this down is uncheck Simulate by Moves. I can right click and simulate that again. So now you see the virtual tool that we set up, the engraver, and that's being simulated for us. And some of the things that you're looking for here is you're looking to make sure that it doesn't cut all the way through the material. Something would be wrong because we're only going down 0.02 of an inch. Go ahead and make that go full speed. So I'm just going to zoom in and take a look at that. Okay, so let's set up our next machining pass, which is also going to be an engraving, but this time it's going to be thicker because we're going to use our Fishtail end mill, which has a 1/16 of an inch diameter. And we're also going to step down into the material deeper. So we're going to go down into the material 0.04 inches. And when we step down, we're going to have to step down in increments of 0.02. So I'll go to 2-axis and I'll choose engraving. Now the drive containment regions that were previously selected show up. So I need to click on remove all. And I'm going to select my new drive containment regions. And this layer is turned off at the moment. Turn it back on, and I'm going to right click and choose select objects, and I'll press enter. Next I need to set up my tool. So I'll click on edit, create select tool, and for this tool I'm going to choose a flat mill, and I'm going to rename this Fishtail 1/16. And the tool diameter is 1/16 of an inch, so 0.0625. The tool length is a 1/2 inch, 0.5. The shoulder length, it doesn't really have a shoulder where the shank gets thicker. So I'm going to keep the shoulder length also set to 0.5. And the flute length is going to be a little bit smaller, so I'm going to set that to 0.4. The holder diameter and holder length can all be a 1/2 of an inch. I need to click out of that to see my final preview. I'll go over to my feeds and speeds, and it should have the feeds and speeds that I already set for the first Endmill, which was the engraver. So I can use those, and I can click on Save as New Tool. Now if you get an error when you're saving as New Tool, it might be that the tool number stayed as 1, and we can't have two tool numbers both set to 1. So as long as that tool number changes to 2, you should be okay. Okay, so I'm choosing my Fishtail 1/16, just checking my feeds and speeds. So it should remember everything from my last setup, my clearance plane, but you want to just double check all of these settings. Cut parameters at top. Now I'm going to go down a little deeper into the material, as I mentioned. So I'm going to go down 0.04, but I want to make sure that I'm doing that in increments of 0.02. So when I click out of that into my rough depth shows up as 0.04. So it's going to cut down too deep. So I need to change that to 0.02 and click out of that, and my finished depth will automatically update. So I'm doing a rough depth of 0.02 and a finished depth of 0.02. So I'm going to make 2 passes into the material. Right? Entry and exit can both be set to none. Sorting should be minimum distance sort, and I can click on generate. So now I want to go ahead and I need to rename this, because when I post this file I'm going to have 2 engravings, and I'm not going to know which Endmill to put into the machine at any given time. So I can right click on this and choose rename, and this will also be an engraving pass, but I'm going to call it the name of my Endmill. So this is going to be Fishtail, and I can't put in 1/16. I can't type that in, and this took me a little bit of time to figure out, because what happens is when I go to post this, it wants to name the file exactly what I've named it here, Fishtail 1/16, and the computer freaks out with that. You can't have forward or backward slashes in your computer file names, so it won't post it, and you'll think something's wrong with your computer. You'll shut it down, you'll restart it, and it still won't post it. It's because of that forward slash. So I'm just going to type this out longhand 1/16, and then I should be okay. And I'm going to go ahead and simulate this. So that went pretty quick. Let me uncheck simulate moves and simulate that again. So it's going to do each one of these lines in 2 passes. One at the 0.02, and then it's going to step down to the 0.04. So you see it making 2 passes in each one of the lines. And if I turn off my stock visibility, I can zoom in, and the blue lines represent the passes. And you see it stepping down in 2 passes. And if I click on my engraving and I zoom in, that only has 1 blue line. So it's only going down to 0.02. Okay, I'm going to turn my stock back on. Okay, so now we've set up our very thin lines with our engraving, and we've gone a little bit thicker and a little bit deeper with our Fishtail 1/16. Now I'm going to go even thicker with our 1/8 inch Endmill. So I'm going to set up another engraving pass, and I'm going to remove my previous drive containment regions, and I'm going to select a new one, turn that layer on, and select objects. So it's just the one I have here, and I'll hit the enter key, and I'm going to go over to tool, and I'm going to create a new tool. Now it's important when you're actually milling that each time you change the end mill, you re-zero the Shapeoko. That's very important. So I'm going to edit, create, select tool, and this is going to be a flat mill, and I'm just going to rename it flat mill, and this will be 1/8 inch. So the tool diameter is going to be 0.125. The tool length, shoulder length, and the flute length, those can all stay from the fishtail. The shank diameter is also going to be 1/8 inch, so 0.125. I click out of that to get an update in my preview. And just making sure that my feeds and speeds carried over. And I can click on Save as New Tool. Now here's that error I was talking about. I'm glad this came up. Tool number is repeated. Do you want use? We're missing a 2 in there. Do you want use a non-repeated tool number? Yes. And if I go back over to properties, it's renamed that tool number to 3. I can click OK. And now I have my flat mill 1/8. I can select that. Go over to feeds and speeds, make sure those carried over. Clearance plane looks good. My cut parameters at top, total cut depth. Okay, I'm gonna go down my total cut depth of 0.04, and I'm gonna step down in 2 levels. So I'm changing my rough depth to 0.02, and I click on the finish depth, and that'll automatically update, so it splits it into 2. My entry and exit can be none, and my sorting can be minimum distance sort, and I can click on generate, and I'm going to rename this. This is going to be my flat mill 1/8, and I could use this for either my single spiral upcut or my straight dual flute downcut end mill. I can experiment with both of those. The tool is really still the same. The diameter and the length of it and so on is still the same. So I can go ahead now and I can simulate this. Let's do that again. So it's going to draw the entire curve down at 0.02, and it's going to step down another 0.02. Okay, my last machining operation that I'm going to look at is not engraving. It's going to be pocketing. Pocketing will go in and remove the stock within a defined boundary. So if I turn on my pocketing layer, I'm going to go back over to program and get out of simulate, and I'm going to select the objects on that layer. So there I have 2 polylines, and it's going to take away the stock inside of those polylines at a certain depth that I set that to. So I'm going to go really deep with those. I'm going to go down 0.06, so I'm going to have to step down 3 levels of 0.02. So I'm going to go up to 2 axis. It's not engraving. This is pocketing. I choose pocketing. Remove the previous drive containment regions. Click on select drive containment regions, and I'll right click on my pocketing layer and choose select objects. So you see my layer structure is really working out for me. So you really want to organize your file and name your layers by the machining passes that you're doing. Okay, I'll hit enter. Okay, I can use my flat mill 1/8. I want to use the larger diameter end mill. If I use the other ones, it's going to take longer to remove the pocket. feeds and speeds carried over, clearance plane. Okay, now this is something we haven't looked at in the cut parameters. There's something called a step over. Because this pocket is larger than 1/8 of an inch, which is my Endmill size, it's going to start in the middle and then step over a distance and mill and step over a distance and mill and keep milling until it fills the entire pocket. Now a good rule of thumb place to start is a tool diameter of 25%. If I try to take away too much on my step over, I can break the bit. Now you can decrease this if you want it to have a finer appearance. You can start to increase this down to 10% or 5%, or you can actually put in a distance. So for right now, I'll keep that tool diameter set to 25%. I'm going to go over to my cut levels, and I'm going to make sure location of cut geometry is at top. My total cut depth is going to be 0.06. My rough depth, I'm going to set that to 0.02. Now it automatically sets the finished depth to 0.04, and that's more than we want to step down at any given time. But I need to look down here and look at the actual depth cut, and rough depth is 0.02 and finish is 0.02. So what's going to happen is it's going to go down and do the rough, and then for the finish it needs to go down to 0.04, so it's going to do that in 2 finish cuts, each at 0.02. So when we look at the machining pass, we're actually going to see 3 of these blue lines, 1 for the rough and 2 for the finish. Entry and exit, I can keep that at the default. Advanced cut parameters, I'll keep that at default. Sorting, I can choose minimum distance sort. I'll go ahead and click on generate. And this might happen to you too. For some reason this popped up above my work 0. I like to keep these all, of course, under work 0 and in the order that I'm going to actually mill them. So I'm moving from thin to thickest, and then my pocketing. And I'm going to go ahead and simulate that. So let's go in a little closer. And we can simulate that again. If I turn off my stock, I can see all 3 of those passes. So there was the rough and the 2 finish. And I'm going to go ahead and turn off my part. Part might be on by default, which is the original stock. So I'm going to go ahead and turn that off so I can see this better. Okay, and then you can go through these previews one at a time just to make sure it's exactly what you want. Okay, so that's it for the introduction to Shapeoko milling.